The next equation that we're going to work with is y equals x squared plus x plus 1. So again, we're going to make our t-chart. This equation is a little bit more complicated, so you might need more room to work. So what I'm going to do is make this dual pages. So it might be kind of hard for you to see, but we have y equals x squared plus x plus 1. So I'm going to do -2, -1, 0, 1, and 2 in my t-chart again. So my equation was y equals x squared plus x plus 1. So first I'm going to plug -2 in for all of the x's in the equation. So I do -2 squared plus -2 plus 1. -2 squared means -2 times -2, that's 4. Then I have plus -2 plus 1. 4 plus -2 is 2. 2 plus 1 is 3. So at -2, my point is 3 for the y. Make this a little bit bigger. So I'm going to plot the point -2, 3. So I go 2 to the left and up 3. Then I do the same thing, but this time I'm going to plug in -1. So I do -1 squared plus -1 plus 1. So -1 squared is 1. 1 plus -1 is 0. 0 plus 1 is 1. So when x is -1, y is 1. So a 1 to the left, up 1. Then I do the same thing, but this time I'm going to do it with 0. So I do 0 squared plus 0 plus 1. 0 times 0 is just 0. 0 plus 0 is 0. 0 plus 1 is 1. So I go over 0, up 1. Right now you might be thinking, wow, that doesn't look like a U shape at all. They don't have flat parts in them like that. But we're just going to keep going because this actually does something special right here that I wanted to show you. So next I plug in 1, back over here for my equation. 1 squared plus 1 plus 1. So that was x squared plus x plus 1. So 1 squared is 1. 1 plus 1 is 2. 2 plus 1 is 3. So I'm going to go over 1, up 3. And lastly, I'm going to do the 2 again. So, but this is a positive 2, I already did -2. So I do 2 squared plus 2 plus 1. 2 squared is 4. 4 plus 2 is 6. 6 plus 1 is 7. So I go over 2, up 7. Now, because my U shape looks like it's going to be flat at the bottom, I have to find my vertex. So these two look like they're across from each other. Probably my line of symmetry is going to go right in the middle of here. Probably. So I need to figure out what point right in this area is my vertex going to be. Where's that middle point of my U going to be? Since I have a dot on 0 and a dot on -1, I'm going to go halfway in between that. Halfway in between that would be -1/2. So now in my equation, I'm going to put in -1/2. So instead of y equals x squared plus x plus 1, I'm now going to do y equals -1/2 squared plus 1/2 plus 1. Now I know this is a fraction, so that might stress you out a little bit, but just go with it. You can totally do this. -1/2 times -1/2. So negative times negative is positive. 1/2 times 1/2 is a 4. Oh, sorry, this is supposed to be negative. So then I have a 4 plus -1/2 fourth plus negative a half happens to be negative a fourth. Bring down my plus 1. Negative 1/4 plus 1 is positive 3/4. So when x is negative a half, y is going to be positive 3/4. So I go over negative a half, up positive 3/4. So my vertex is on the line x equals x equals 3. Sorry, the vertex is on x equals negative a half. That's going to be this pink dotted line going up here. That's my line of symmetry. The vertex and your line of symmetry are always going to have the same x value. So connect these dots. My y-intercept is this line right here. I'm going to zoom back in on this. It'll be easier for you to see. All right, so this blue dot right here is my y-intercept because that's where the parabola crosses the y-axis. This black dot right here is my vertex. So like the last graph, this vertex is a minimum because it's the smallest point in my parabola. And then this polka dotted purple line up here, that was my line of symmetry. So in the last graph, the line of symmetry was the y-axis, but in this graph, it's x equals negative a half. We have one more to do. It is y equals negative x squared plus 2x plus 3. So again, I'm going to make this 2 pages so we can show our work better. We're going to make our same t-chart. We can even use the same numbers if we want. So we're going to start by plugging negative 2 in for all of the x's. So I'm going to do this means the opposite of negative 2 squared plus 2 times negative 2 plus 3. So we need to think about order of operations. First I do exponents. Negative 2 squared means negative 2 times negative 2. That's 4. This negative sign in the front turns this into the opposite of whatever happened here. So the opposite of 4 means negative 4. Then I have plus 2 times negative 2 is negative 4. And then I'm just going to bring down this plus 3. So I add from left to right. Negative 4 plus negative 4 is negative 8. Negative 8 plus 3 is negative 5. Bigger for us. So I'm going to go 2 to the left and down 5. Then I do the same thing again, but this time I'm going to use negative 1. So I'm going to do the opposite of negative 1 squared plus 2 times negative 1 plus 3. So first I do negative 1 squared. Negative 1 times negative 1 is positive 1. Then I have to do the opposite of that. Then I do 2 times negative 1. That's negative 2. And I bring down my plus 3. Negative 1 plus negative 2 is negative 3. Negative 3 plus 3 is 0. So at negative 1, my y is 0. So over 1 up to 0. Next, I do the same thing, but this time I'm going to use 0. So I do the opposite of 0 squared plus 2 times 0 plus 3. Well, 0 squared is just 0. The opposite of 0, well, there really isn't one, so it's just 0. 2 times 0 is 0, and I bring down my plus 3. So 0 plus 0 plus 3 is just 3. over 0, up 3. Then I continue on. I do the 1 in place of the x. Opposite of 1 squared plus 2 times 1 plus 3. 1 squared is 1. The opposite of that is negative 1. 2 times 1 is 2. Bring down my plus 3. Negative 1 plus 2 is 1. 1 plus 3 is 4. So I'm going to go over 1, up 4. And last I'm going to do my 2 in place, this 2 in place of the x's. So the opposite of 2 squared plus 2 times 2 plus 3. 2 squared is 4. Opposite of that is negative 4. 2 times 2 is 4. Bring down my plus 3. Negative 4 plus 4 is 0. 0 plus 3 is 3. So I go over 2, up 3. So now I'm going to switch back over to this page so it's bigger for you. Alright, so this is what our graph looks like right now. You can see my parabola at this time is upside down, but I don't know exactly where it's going to land. So I'm going to go ahead and do some work with my axis of symmetry first and work on some reflection. So this is my vertex up here. Remember earlier I said that the vertex and the axis of symmetry are always located on the same x equals line? Well, in this case, my axis of symmetry is at x equals 1 because we're at a positive 1. I can do some reflecting of this point over here and of this point over here. The line of symmetry or the axis of symmetry shows you how, or it's like the middle. So it's reflecting left side of the parabola to the right side of the parabola. So up here you'll see that this is 1 away from the purple line, and this is 1 away from the purple line, the line of symmetry. So we just count. This is 2 away from our line of symmetry, not from the axis, or the origin. So we're going to go, since it's 2 away on the left, we have to go 2 away on the right. Down here we have 1, 2, 3. We're 3 away from the axis of symmetry, so over here we'll go 1, 2, 3. Now I can just finish out my parabola nice and easy. So our y-intercept is still where the line hits the y-axis. That's going to be up here. The coordinate for the y-intercept is over 0, up 3. Here's my vertex. The coordinate for my vertex is over 1, up 4. And then I have what's called x-intercepts, and we haven't talked about those yet because our other 2 graphs didn't have any. X-intercepts are where your parabola crosses the x-axis. So you might remember that this line is the x-axis. So we're looking for the point where our line, our parabola, crosses them. So that'll be right here and right here. So this is at over 3 up 0. And this one from the origin is at negative 1, 0. So both of these are my x-intercepts. So now I'd like you to pause the video, or actually you can stop it, and then do a couple practice ones on your own. But then I have a really big problem for us to do when we get all finished with that.